Hello everyone, welcome back to NG classes. I hope you all like my previous video, and if it helped you, please do subscribe my channel. And yes, if you want me to discuss any other topic, please comment in the comment box. So today we are going to discuss mensuration. Now mensuration means to measure something. This is the part of the geometry where we will learn how to measure perimeter, area, volumes, etc. of any 2D or 3D shapes. So let's start the discussion with some basic concept. Let's see what's the difference between area and perimeter of any two-dimensional shapes. At first, let's see what's perimeter. So here we are having a rectangle. Let's name it. Let's say it's a rectangle A, B, C, and D. Now, let's suppose we want to move along the boundary of this rectangle, and we will start from point A. So, let's start from point A and let's move along AB. At a certain point of time, we will be at point B, right? After that, let's move along BC, and then after that, we will move along CD. So, now we are at point D, right? Now, let's move along DA and stop. So, we covered DA as well, and now we are at point A. So, we started from point A and ended at point A. This way, we have covered the perimeter of the rectangle ABCD. Whenever we are walking along the boundary of any shape, be it circle, square, triangle, or any two-dimensional shape, that time we are covering the perimeter of that specific shape. Now, what's area? Area means the space enclosed by the boundary line. This enclosed means covered by the boundary line. Now let's say we want to do gardening on this rectangular plot ABCD. So let's do the gardening. So can you see our green color garden? Yes, that's the area of this rectangular plot ABCD. Now let's discuss what's the difference between surface area and volume of any three-dimensional shape. Now let's focus on surface area at first. Here we are having one cylinder. For surface area, as the name suggests, we have to find the area of each and every surface. Let's see how many surfaces are there in this cylinder. So, we are having a circular top. As we can see here, we are having a circular bottom having the same radius. And also, when we will open the curved part, we will get a rectangular seat like this, right? So total, how many surfaces are there? This is the top surface, and we will find area of this surface. This one is the middle surface, the rectangular seat. We will find the area of this surface as well. And also we will find the area of the bottom surface. That means bottom circular base, area of this surface as well. And when we will combine area of each and every surface, then we will get total surface area of this cylinder. Now, if we have to find only the curved surface area of the cylinder, then we just have to find area of this rectangular seat, because the curved part is made up of only the rectangular seat, right? Now let's see what's volume. Now volume means total amount of space occupied by any three-dimensional shape. So here we are having a cylinder. Wherever we will place this cylinder, definitely it will occupy some space. The volume will represent the total space occupied by this cylinder. Whereas capacity is slightly different from the volume. Now capacity means how much amount of liquid or maybe gas this cylinder can occupy. Now let's solve few questions from the exercise. So here our question says, Mrs. Kosik has a square plot with the measurement as given in the figure. So we are having a square plot with the measurement already given, that is side of the square is 25 meter. She wants to construct a house in the middle of the plot. So in the middle of the plot, she wants to construct a house. Now here we can see the house she has constructed in rectangular shape. Now a garden is developed all around the house. Can you see the green color? It's the garden. Okay. Find the total cost of developing a garden around the house at the rate of 55 rupees per meter square. So here this unit, square meter, is the unit for area. That means here we have to find the area of something. Now area of what? Let's read it again. Find the total cost of developing a garden. So garden's area. We have to find garden's area, then only we will be able to find the total cost for developing a garden at a given price. So let's do it. Here at first we will find the area of the square plot, the total plot. Let's see what's the area of the total plot. So area of plot is equals to, it's in square shape. So formula for square's area is side square, which means 25 square, and that will give 625 meter square. Now inside the square plot there is a house. So let's see how much area is occupied by the house. Area of house it's a rectangle. So we will apply the area of rectangle's formula. Length and breadth is already given in the figure. So here we got 300 meter square as the area of the house. Now we have to find the area of the garden. So to find the area of the garden, when we will take the total area, that means area of the square plot, and from that if we will take out or exclude the area of the house, then we will left with the area of the garden, right? Let's do it. So area of garden will be total area, that means 625, minus area of the house. That will give 325 meter square. Once we got the area of the garden, now easily we will be able to calculate the cost of developing garden at a given price. So for 1 meter square, the price is rupees 55. So for 325 meter square, what will be the price? It will be 325 times 55, that is 17,875 rupees. Now let's discuss about quadrilateral's family tree. I'm pretty sure that you must have created your own family tree. Here we are going to discuss about quadrilateral's family tree. As we can see here, the head of the family member is quadrilateral. So whatever property or formula will be applicable for this quadrilateral, other member of the family will also follow the same, apart from having their own particular qualities or properties. So quadrilateral, as we know, is a polygon having 4 sides and also sum of interior angles of the quadrilateral is equals to 360 degree. This will be valid for the other members as well. Now let's move to the first generation. Here the first member is trapezoid, which is also known as trapezium. Let's say it's a trapezium ABCD. Here side AB is parallel with side CD, whereas side AD and BC are not parallel with each other. And also the parallel side, that means AB and CD, are known as bases of the trapezium, whereas the non-parallel side, that means AD and BC, are known as legs of the trapezium. When we will extend the parallel side, let's extend it. Then as we can see, side AD or leg AD will work like a transversal line. So we can see the sum of the angle A and D will be 180 degree because it's a interior angle lying on the same side. Similarly, here BC is also working like a transversal line. So we can also say that the sum of the angle B and C will be 180 degree. Alright. The diagonal of the trapezium, as we can see here, the diagonals are BD and AC, both will bisect each other. Now what's the meaning of bisecting each other? Bisecting means cutting each other in half parts. So here let's say both the diagonal are intersecting at a point O, then AO will be equals to OC. I am talking about the length of AO and OC, and also OD will be equals to OB. Alright. Now let's move to the next member of this family, that is parallelogram. Let's say it's a parallelogram PQRS. Here side PQ and RS are parallel with each other, and also the length of the side PQ and RS are equals to each other. Similarly, side PS and QR are parallel as well as equals to each other. So opposite side of the parallelogram are parallel and equals to each other. Here angle P will be equals to angle R, and also angle Q will be equals to angle S. Just like the trapezium, here also the diagonal of the parallelogram will bisect each other. And since here we are having two pair of parallel lines, hence sum of adjacent angle will be 180 degree. So any two adjacent angle we can take, let's say angle P and angle Q, the sum has to be 180 degree. Alright. Let's move to the next member of this family, and that is kite. Now this kite is quite different from the other two members of this family. In kite, we don't have any parallel side. Let's name this kite. Let's say it's a kite MNOP. So M, N, O and P. Here side MN will be equals to side NO, and length of the side PM will be equals to the length of the side OP. Diagonal of the kite intersect each other at right angle or 90 degree. So in between both the diagonal we will get 90 degree. In a kite, the angle between two different length side. So different length side means MN and PM are of different length, right? So angle between that means angle M, and angle between NO and OP, that means angle O, will be equals to each other. Now there is one more property which says that longer diagonal of the kite bisect the smaller diagonal. So be careful here, both the diagonal are not bisecting each other just like the previous two members. Here longer diagonal will bisect the smaller one. Now let's see which one is the longer diagonal. To decide which one is the longer diagonal and which one is smaller, you can just observe the figure and you will understand. Otherwise, if that is confusing, then you can take the help of ruler. Here we can see MO is the longer diagonal and PN is the smaller diagonal. Let's say both the diagonal are intersecting each other at a point T. So this point is T. Now the length of NT will be equals to length of PT, because longer diagonal cutted the smaller diagonal into equal parts. Alright. Now let's move to the next generation of this family. Here the first member or the sub part of trapezium is isosceles trapezium. Now isosceles trapezium will contain all the property of quadrilateral as well as trapezium. Let's name it. Let's say it's PQRS. Now as we know, isosceles means two sides same. So here isosceles trapezium means a trapezium having two sides same. Here two sides will be legs. Here legs of the trapezium will be of same length. Leg PS will be equals to the length of the leg QR. Apart from this, it will follow all the property of trapezium. Let's move to the next member of this family, that is rectangle. Now this rectangle is the sub part of parallelogram. So it will contain all the property of parallelogram as well as quadrilateral. In a rectangle, each and every interior angle is of 90 degree. And rest of the property will be the property of the parallelogram. Now let's move to the next member of this family. Rhombus is the next member, and rhombus is also sub part of the parallelogram. So it will contain each and every property of the parallelogram. Apart from that, all the sides of the rhombus are of equal length. And also diagonal of the rhombus bisect each other at right angle. So as we can see here, both the diagonal will make 90 degree with each other. Now let's move to the last member of this family, that is a square. Now a square is a sub part of rectangle and rhombus. So it will contain all the property of rectangle, rhombus, parallelogram and quadrilateral. That's it. Now let's discuss about trapezium. Let's say it's the trapezium ABCD. Here we will find the area of the trapezium. So let's say the side AB is given as A centimeter, side CD is given as B centimeter, and the height BO is given as H centimeter. Here AB and CD both are parallel with each other, whereas AD and BC are not parallel with each other. Let's find the area of the trapezium by using the figures which we know already. So here we can see we are having one rectangle and one triangle. The name of the rectangle is ABOD and the name of the triangle is triangle BOC. Can you see it? So we will find the area of the rectangle. Then we will find the area of triangle BOC. When we will add both the area, then we will get the area of the trapezium. Let's do it. The area of rectangle ABOD is equals to, here this rectangle is having length A and breadth H. So A times H, or we can also say AH, right? Please don't get confused with this B centimeter, because here CD, total CD is B centimeter. Okay. Now let's find the area of the triangle. Area of triangle BOC. So the area of the triangle's formula is 1/2 times base times height. So height, we already know the height of the triangle. It's a right angle triangle and the height is H. What's the base? Can you see this yellow color base? CO. How we will find CO? So here we know CD, the total length is B centimeter and AB is A centimeter. So can we say CO will be B minus A? Let's substitute it here. So 1/2 times B minus A times H. Now, as we have discussed, when we will add both the area, then we will get the area of the trapezium. Let's find it. Let's apply the distributive property and open the bracket. So here we are having like terms, that is AH and half AH. That means 1 AH minus half AH will be half AH, right? So half AH plus half BH. When we will take out the common factor from here, we will have 1/2 times H, we can take out common, and A plus B will be in the bracket. And this is the formula for area of the trapezium. Now let's see how to find the area of general quadrilateral. Let's give it a name P, Q, R and S. Now let's draw the diagonal of this quadrilateral. So let's say SQ is a diagonal and let's assume this SQ is D centimeter or D unit. Can you see two triangles over here? Yes, I'm talking about triangle PQS and triangle SQR. When we will find the area of the triangle PQS and then the area of the triangle QRS, and once we will add both the area, then we will end up getting the area of this given quadrilateral. So let's find it. Let's drop the perpendicular from here. Let's say it's H1 and let's drop the perpendicular from R as well. Let's say it's H2 and let's find the area one by one. Now this method is called triangulation. And we can use this method when we don't know the specific name of the quadrilateral. So area of triangle PQS will be 1 by 2 times base. Now we can see the base is D and the height. Area of triangle QRS will be 1 by 2 times. Now can you see the base of the triangle QRS is also same as the base of the previous triangle. So here also the base is D only times H2. Now let's add both the area so that we will get the total area. Here we can take out common half and D. So let's take it. And that's it. We have got the area of the quadrilateral PQRS. Now let's find the area of the parallelogram. Let's say this is a parallelogram PQRS. Here side PQ will be parallel to side RS, this with this, and side PS will be parallel to side RQ, and it will be equal with each other as well. Then if we are taking side PQ as B unit, then side SR will also be B unit. And if side PS is A unit, then side QR will also be A unit. Now let's find the area of this parallelogram just by splitting it into triangles. So let's join P with R. Let's draw the diagonal PR. So here we got the diagonal PR. Now here we can see two triangles, triangle PSR and triangle PRQ. Now to find the area of this parallelogram PQRS, once we will find the area of triangle PSR and we will find the area of the triangle PRQ, and when we will add both the area, then we will get the area of the parallelogram. So let's find the area of triangle one by one. So PSR. Here let's say this SR as a base. So what we need for the area of the triangle? Height and base. So do we know height over here? No. Let's drop the height. Let's say PT is H. Now let's find the area. So 1 by 2 times base. Base is B and height is H. Now let's find the area of triangle PRQ. Here also we need to drop the height, right? So let's drop it. Now can you see RM? Here PT and RM must be same. If PT is H unit, then RM must be H unit only. Why? Because two parallel lines must have same distance between each other always. So PQ and SR is a parallel line and we are just getting the distance between these two parallel lines, right? Let's find the area of the other triangle. So this will be 1 by 2 times, what's base? Base is B only because the opposite sides are same, times H. Now let's add both the area so that we will get the area of the parallelogram. So 1 by 2 BH plus 1 by 2 BH will be only BH. which can also be written as just base times height. And this way, this base times height, this is the formula for area of the parallelogram. All right. Now let's derive the formula for area of the rhombus. So let's say it's a rhombus P, Q, R, S. And as we know, all the sides of the rhombus are of same length. So side PQ, QR, RS and PS, all the sides are having same measurement. Let's say all the sides are of A unit. Let's draw the diagonal. Now, as we know, diagonal of the rhombus bisect each other at right angle. So each and every angle is 90 degree. All right. And we also know that diagonal of the rhombus are not of same length. So here the diagonal PR and the diagonal SQ are of different lengths. So let's say the diagonal SQ is D1 and the diagonal PR is D2. Now let's find the area of this rhombus just by taking the triangles. So let's take the triangle PQS and the triangle QRS. Once we will add both the area, we will end up getting area of the rhombus. So triangle PQS area and triangle QRS area. It will be 1/2 times base. So here we can see the base of this triangle is D1 times height. So here the height, do we know the height? This D2 is the length of the diagonal PR. Only PO, that means D2/2, because both the diagonals are bisecting each other. Other one is also D2/2, right? So let's take height as a D2/2. Similarly, for the other triangle, that means QRS, 1/2 times base. Now base is D1 and height is D2/2, which can also be written as D1/4. Here also D1/4. Let's add both the areas. So area of the rhombus, so we got D1/2. Or we can also say it's 1/2 times D1 times D2. That's the formula for area of the rhombus. We just have to multiply both the diagonal and then we have to divide it by 2. Now let's solve some questions. So here our question says find the area of the rhombus whose side is 5 cm and whose altitude is 4.8 cm. If one of its diagonal is 8 cm long, find the length of other diagonal. Let's draw the figure at first. So here we are having a rhombus. Here the side of the rhombus is given as 5 cm and we know each and every side of the rhombus are of equal length. So all the sides are 5 cm only. And altitude is given as 4.8 cm. So let's drop the altitude. So if one of the diagonal, let's say BD, is 8 cm long, then we have to find the length of the diagonal AC. So as we know, rhombus is a special case of parallelogram. So to find the area of the rhombus, we can also use the formula for area of the parallelogram, that is base times height, right? Let's do the multiplication. So base is 5 cm and height, altitude is already given as 4.8 cm. Let's do the multiplication. So we got 24 centimeters square. Now we also know that the formula for area of the rhombus, we are having one more formula in terms of diagonal, that is 1/2 times D1 times D2. So let's use that formula. Area of rhombus can also be found as 1/2 times D1 times D2. Here we know one of the diagonal, so let's substitute it. 1 by 2 times 8 times d2. Now let's compare both the area because we are talking about the same rhombus in both the cases. So according to the question, 24 is equals to 1 by 2 times 8 times d2, and from here we will get the value of d2 as 6 centimeter. Now let's discuss about solid shapes, also known as three-dimensional shapes. Here we will discuss about the surface area of cube, cuboid, cylinder and cone. So let's focus on cuboid at first. Now as we know, surface area means area of each and every surface combined together will give us the surface area of this cuboid. So let's see how many surfaces are there in this cuboid. So when we will open it, it will look something like this. Now let's open it completely. So when we will open it completely, it will look. Now we need to understand that this is the length of this cuboid. This part is the breadth of this cuboid and this is the height of this cuboid. So here also when we have opened the figure, please don't get confused. This is the bottom part here. This is the front side. This one is the back face. Here we are having the top face, which just came along the back side. Now here we are having the right side of this cuboid, and here we are having the left side of this cuboid. So the bottom part, if we will focus on the top and the bottom part, here we can see this is the length of this cuboid and this is the breadth of this cuboid. So for top, we are having length, we are having breadth. Similarly, for the bottom, we are having length and we are having breadth. When we will open it from the front, we will see length will come along with one of the side and height will come along with the other side. So for the front part, we will have length and we will have height. Similarly, for the back part, we will have length and we will have height. Now for the right side, let's see, we are having one of the side as a breadth and another side as height. So we are having breadth, we are having height. Similarly, for the left side, we are having breadth and we are having height. Now let's write area of each and every surface. So here we are having length times height. Here we are having length times breadth, right? Similarly, for the back side, we are having length times height as the area. For the top, we are having length times breadth. For the left side, we are having breadth times height. And for the right side, we are having breadth times height. Now let's add all of them together. So we will have 2 times length times breadth plus breadth times height plus height times length. And that's the formula for surface area of the cuboid. Now just like cuboid, we will be able to find the surface area of cube as well. Now as we know, each and every side of the cube are of same length. So we can take this one as a centimeter, this one as a, this one as a, all side as a only. Alright. So each and every square surface will have area as a square, a square, a square, a square, a square and a square, and hence once we will add all the areas, we will get the surface area of the cube, that means 6a square. This is the formula for surface area of cube. Now let's find the surface area of cylinder. So now we will find area of each and every surface and we will combine them together. So let's find it. So as we can see, As we know, the circle has radius r and the bottom circular base also has the same radius, that is r. So this circle is having radius r and the same radius the bottom circle also having. Now the length and the breadth of this rectangle. So we know the breadth of this rectangle is the height h, alright, and the length of the rectangle, when we will fold it in rectangular sheet's length will work as circumference of the circle, right? So this length will be same as the circumference of the circle, 2 pi r. Now let's find area of each and every surface. So the upper circle is having area pi r square. The bottom circle is also having the area as a pi r square. And the rectangle is having the area as length times height. That means length is same as the circumference of the circle times height. Now let's add all of them together. So 2 pi rh plus pi r square plus pi r square, and that will give 2 pi rh plus 2 pi r square, which can also be written as 2 pi r in bracket r plus h. And this is the formula for total surface area of the cylinder. Now, if we have to find only the curved surface area of the cylinder, we will take only the rectangular sheet's area, that means 2 pi rh. This is just curved surface area. Alright. Now let's find the volume of these three-dimensional shapes. So let's start with cuboid. So as we know, volume means amount of space occupied by three-dimensional shape. Now here we can see the space has been occupied by the base of the cuboid, and due to the height also it has occupied some space. So the volume formula in general is base area times height, which is valid for all the three-dimensional shape. So here we are having base area as length times breadth and times height. That means the formula for volume of the cuboid is length times breadth times height. Let's find the volume of the cube as well. So volume of the cube will be again base area times height. So base is having the area as a times a or a square, and since it's a cube, so height is also a. Hence the volume of the cube is a cube. Alright, let's find the volume of the cylinder. So here also volume is equals to base area times height. So base area, when we will find the area of the base, which is a circular base, it will be pi r square, and height of the cylinder is h, so times h. Hence the formula for volume of the cylinder is pi r square h. Alright, I hope you have understood the whole concept on mensuration. Thank you.